Hello students and welcome to my channel Maths Hub. So today in this video I'll tell you about infinitely many solutions in how to solve it in non-homogeneous system of equations. So if you have seen my previous videos, I have told about the conditions to solve a system of equations using the rank method, and I've also told you how to solve a no solution and unique solutions. So in this video we'll focus on infinitely many solutions. So if you remember the conditions for infinitely many solutions, the condition says that rank of A augmented B and rank of A should be equal, but they should be less than the number of unknown variables. So let us try to focus on this. So we have to find all the solutions for the system of equations. So you know here that the number of unknown variables are x1, x2 and x3. So there are three unknowns. So let us first try to convert this into the form of a matrix. And you can see that the matrix converted is 1, 2, minus 1, 3, minus 2, 2, 7, minus 2, 3, x1, x2, x3, and 1, 2, 5. So one method is when you write the matrix in the form of A augmented B. And the second form of writing the equation is you write it in the same form and you operate the elementary transformations, and whatever you apply here, you apply the same transformation on the right hand side also, right? So this is what we try to do. So you can do it by both methods. It hardly matters. So in this case, you can see that we first apply the row transformation. R2 is equal to R2 minus 3R1. And then we apply R3 is R3 minus 7R1. You can see that the leading element is 1. So you can easily make these two elements 0. So on applying these transformations, the following matrix gets converted to this. And after this, we can see that we have this element minus 8 and this element is minus 16. We have to finally make this element 0. So we apply the transformation R3 is R3 minus 2R2. And when we apply this transformation, we get the matrix as 1, 2, minus 1, 0, minus 8, 5, 0, 0, 0. X1, x2, x3 is 1, minus 1 and 1. So if you check the, the rank of A augmented B, you'll find that the rank of A augmented B is complete 0 row. So it is 2. And if you find the rank of A, again you can hide the coefficient, the B matrix, you will again find that there are 2 non-zero rows. So rank of A augmented B, you can find that it is equal to rank of B and it is less than 3. Isn't it? So it is definitely going to give you a infinitely many solutions. So how to get infinitely many solutions? We'll frame back the equations. So the first equation is x1 plus 2x2 minus x3 is equal to 1. And the second equation will be minus 8x2 plus 5x3 is equal to minus 1. So when it is infinitely many solutions, that means the solution is dependent on something. Only then you will get infinitely many solutions. So what we do, we can assume that let x3 is equal to k, right? So when x3 is equal to k, you can substitute it here. So we get minus 8x2 plus 5k is equal to minus 1. So we get x2 is equal to minus 1 by 8 times minus 1 minus 5k. So that turns out to be, you can multiply with a minus sign. You will get 1 by 8 times 1 plus 5k. And when you substitute x2 in the first equation, x2 and x3, you'll get the value of x1. So we get x1 as minus k by 4 plus 3 by 4, x2 as 5k by 8 plus 1 by 8, and x3 is k. So you can see that all these variables, they are dependent on k. On giving different values to k, you'll get different solutions. So that is why the system has infinitely many solutions, right? So I hope this is clear. So let us try to one more problem. So we have to test for consistency and solve the system of equations. So again, we try to convert them in the form of A augmented B. So in my video, I've tried to cover up both the types of writing the equations. So here we are writing it in the form of A augmented B. So you can see 5, 3, 7, 3, 26, 2, 7, 2, 10. This is the coefficient matrix. Then we have written an augmented. And then the right hand side vector is 4, 9, and 5. So we try to convert this into a row echelon form. So we have to first make this leading element 1. So we multiply the entire row with 1 by 5. So we get this. And then we apply the first, after the element has been made leading 1, we can use this to make them 0. So we can write R2 is R2 minus 3R1 and R3 is R3 minus 7R1. So we get this matrix, right? So at this stage, you can see that what is rank of A augmented B? It is 2, isn't it? You have a complete 0 row. So similarly, rank of A is also equal to 2. So you can see that both the ranks are equal, but they are less than the number of unknowns. So it is definitely going to give you infinitely many solutions. So how the infinitely many solution will exist? When you frame back the equations, you will get the first equation as x plus 3 by 5 y plus 7 by 5 z is equal to 4 by 5, and the second equation that you will frame is 121 by 5 minus 11 by 5 z is equal to 33 by 5. So again you can assume z to be k. When you assume z to be k, what will you get? You will get, when you substitute z equal to k in this, you will get y as 3 by 11 plus k by 11. And then finally substitute y and z in terms of k in this equation, and you'll get x as minus 16 by 11 k plus 7 by 11. So you can see all your x, y, z is dependent on k. So this leads to infinitely many solutions, right? So let's try one more problem. So you have to find the values of lambda and mu for which the system of linear equations has infinitely many solutions. So you can see that lambda and mu are unknowns. So you have to calculate their value. So again, it's very simple. We first try to convert this in the form of an A augmented B matrix. So you can see 1, 1, 1, 1, 2, 5, 2, 3 lambda. Then we write the right hand side as 6, 10 mu. Now we try to convert this. We apply the row transformation R2 is R2 minus R1, and we apply R3 is R3 minus 2R1. So when we apply these two transformations, we get 1116, 0144, 01 lambda minus 2 and mu minus 12. Then we can finally make this element also 0 by applying R3 is R3 minus R2. So now at this stage, since it is given that it has infinitely many solutions, so that means rank of A augmented B should be equal to rank of A, and it should be less than 3 because there are 3 unknowns. So if it is less than 3, that means both the ranks must be equal to 2, right? So if both the ranks are equal to 2, that means it will have 2 non-zero rows. So that means this row needs to be completely 0, right? If this row needs to be completely 0, that means this should be equal to 0 and this should be equal to 0. So if lambda minus 6 is equal to 0, this will lead to the value of lambda to be 6. And if mu minus 16 is equal to 0, that means mu will become equal to 16. So these are the values of lambda and mu for which the system will have infinitely many solutions, right? So I've given you some problems. I've given you the answers also. So do try these problems. In case you have any doubt, put it in the comment section. And if you like the video, do hit the like button. And those of you who have not subscribed my channel, do subscribe my channel and do share the videos with the ones who need them. And believe in yourself and you will be able to succeed. Thank you so much.